Hey everyone, Teacher Chang here, and today we're going to take a look at piecewise functions, and we're going to write out the equation of these piecewise functions. So let's go ahead and get started. What is a piecewise function? Well, a piecewise function is where we have several pieces of subfunctions that are applied to different parts of the domain. So again, we're going to be looking for several pieces of a function, and we're going to see how they are broken up in different parts of the domain. So here's an example of a piecewise function. And we can see that in this piecewise function, we have it broken up into four different parts. So we have four pieces in this piecewise function. So what we're going to do is we're going to come up with four separate equations, one for each piece, but then yet we're going to put them all together and create one equation for this piecewise function. So in order to do this, since these are all linear equations, linear functions here, we're going to write it in terms of a linear equation. Now we could write out our linear equation in slope-intercept form, or we could do it in point-slope form. I'm going to be writing these out in point-slope form, because it's a little bit easier when we have something like this. So the point slope form has a certain format that looks like this. It's y minus y1 is equal to m times x minus x1. Now, when we write out an equation for a graph, we want to get it so that it says y is equal to something. And that's why we typically write our linear equations in slope-intercept form. So in order to convert this point-slope form so that it says y equals, all we got to do is get rid of this minus y1. So we're going to add y1. We're going to add y1 on both sides. And when we add y1 on both sides, that's going to get us our y by itself. So now the point slope form, if we just kind of rearrange it a little bit, it's now going to look like y is equal to m times x minus x1, and that y1 gets thrown at the end. Now some people will write it in the front, and they might write y1 plus m times x minus x1, which is pretty much the same thing here. But I'm going to leave it in this format right over here. So this is what we want our equations to look like here. So if I take a look at each of these pieces, we're going to go ahead and come up with an equation for each section. So if we take a look at the first section, we're going to go ahead and start off with A. And I want to come up with an equation for that piece right here. Now that piece, for part A, we need a point and we need a slope in order to come up with our point-slope form. So the point that we're going to be starting off with is the beginning point. And that point's at 0, 0. And the slope is our rise over run. So we want to know, okay, well, what is our rise? How high are we going up? And how far over in terms of the entire function or the entire line? So I'm going to go up 5 units and over 5 units. So the slope in this particular case is 5 over 5, which we could simplify to 1. So in this case, the slope is 1. Well, if I go ahead and put it all into our piecewise, into our point slope form, we have our x1 and our y1, and we just substitute. So y is now equal to our slope, and our slope in this case is 1, times x minus x1, and x1 is 0. And then we have to go ahead and add in our y1, and y1 is also 0, so plus 0. So there is a point slope form, but we're going to simplify this if we can. And if we take a look at this, well, 1 times x minus 0 is just 1x plus 0. So this is just going to be y is equal to x. So there's our equation. Now, that equation is not for the entire graph. That equation only goes from 0 to 5. So that's the interval that we're going to be looking at. So the interval for this particular piece is between 0 and 5. So x is between 0 and 5. Now it does include the 0 and it does include the 5. Now you could write it in terms of an inequality like this. Some teachers will go ahead and have you guys write it with brackets and parentheses. Now the brackets just means that it includes the 0 and it includes the 5. Now the parentheses will just state that it does not include that value. And I'll give you an example of that for this next one. So the next piece that we're going to be looking at is part B. And part B is just a flat line. Now, when we have a flat line, again, I'm going to write it in terms of our point slope form. And we can see that the beginning point is located right over here at 5, 5. So the beginning point is at 5, 5. That's the point that we're going to start with. And then I need to figure out, well, what is the slope? Well, the slope, that means the rise over run. And again, the rise is 0. It didn't go up any. So the rise is 0, but it went over 5 units to the right. So we went over 5 units. So it's 0 over 5 or 0. So that's what it should be in terms of our point slope form. We'll just substitute it all in. We have our x1 and our y1, and then we have our slope. So y is equal to our m times x minus x1, and then we're going to add in the y1. So our slope in this case is 0, our x1 is 5, and our y1 is also 5. Now, if we actually simplify this, well, 0 times x minus 5 is just 0. As 0 times anything is 0, and 0 plus 5 is 5. So in this case, y is equal to 5. Now, a little quick note here is that anytime you have a flat horizontal line, it's just going to be that y value. And the y value, if you notice, it's going to be at this 5. So there's our equation for our second piece. We just need to know, okay, well, what's the interval? Well, the interval is along the lines from 5 to 10. So it goes from 5 to 10. But the 5 has already been used. So again, the x value is between 5 and 10. But because we've already used the 5 in the first interval, we're not going to include it this time. So it's just going to be this lesson sign instead of a less than or equal to. And then we'll go ahead and include the 10 at the end. So here, if I were to write this in terms of brackets and parentheses, that means the 5 is not included because it was already included in the previous interval. And then we have our 10, and that one is included, so we're going to use a bracket. So you could go ahead and write out your intervals in terms of an inequality or a bracket. Okay, the next piece that we're going to look at is going to be C here. So C is this piece right over here. We'll do that in green. So I'm going to write that out. And again, what I'm going to do is I'm going to look for the beginning point, and that beginning point is located at 10, 5. So the x value is 10, the y value is 5. And then we're going to look for the slope. And again, I'm going to do my rise over run. And you can always try to find that slope in simplest form, but if you can't really see it, ask yourself, well, what is the rise? How far did we go up from 5 to 15? So that's 10. And what is the run? How far did we go over to the right? That's going to be 5. So rise over run. So that means the slope is 10 over 5, but 10 over 5 can be simplified to 2. So our slope is going to be 2. So now that we have our point, that's going to be our x1 and our y1, and we have our slope. And again, I'm going to just substitute it in. Y is equal to our m times x minus x1 plus y1, and we'll just substitute our values in. So the slope is 2. The x is 10, and then our y1 is 5, so plus 5. Now there's our equation. We could just leave it like that. There's nothing I need to do here. If you want to convert it into slope-intercept form, you're more than welcome to, but we're just going to leave it in point-slope form. It's a lot easier. So now we just need to know, okay, well, what is the interval for this piece? So the interval for this piece is from 10 to 15. Now remember, we already used that 10 in the previous interval. So the x values are between 10 and 15. And since we already used that 10 in the previous interval, I'm just going to use that less than sign because we've already used it right over here. And then I'm going to go ahead and attach the equal sign to that 15 because we do end at that 15. Again, if we want to write it in terms of brackets and parentheses, it's between 10 and 15. It does include the 15, but not the 10. All right, we got one more piece, and that's going to be D, and I'm going to go ahead and do that in red here. So we want to go ahead and write out the equation for this line right here. And I'm going to try to squeeze that in right over here on the bottom here. So D, the beginning point of D is located right over here at 15, 15. Okay, and then the slope of this line, well, again, we'll do our rise over run. To rise, this time we're going down 5, so negative 5, and then over 5. So the slope in this case is negative 5 over 5. Well, negative 5 over 5 is just negative 1. So here we have our x1 and our y1. And again, all we got to do is substitute it into that format. So y is equal to our slope times x minus x1, and we'll just plug in our pieces. So our slope is -1, and then we have 15 for x1, and then we have 15 for y1. So this right here is our equation. Okay, and we want to write out, okay, the interval for this piece is from 15 to 20. So again, if I were to write out the interval from this piece is between 15 and 20. So x is between 15 and 20. Again, we used that 15 earlier, so we use it from the previous interval, so I'm not going to include it. So it's just a less than sign. And then it does include that 20. We have that closed circle and that 20, and that's where our graph stopped. Again, if we want to go ahead and write it in terms of parentheses and brackets, it's between 15 and 20. It does not include the 15, so that's why it's a parentheses, and it does include that 20. So here's our 4 pieces. I'm going to highlight the important information that we need here. So we need the equation for each piece. So we got y is equal to x along the intervals of 0, 5. And we can write it in terms of the inequality order bracket. Our second piece is y is equal to 5 along the intervals of 5 through 10. Again, either in terms of the inequalities or the brackets. And C is is where y is equal to 2 times x minus 10 plus 5 along the intervals of 10 to 15. And last but not least, we have our fourth piece. Y is equal to -1 times x minus 15 plus 15. That's the equation, and it's along the intervals of 15 to 20. So what we're going to do is we're going to use all of that to come up with the actual equation of the piecewise function. So this is how we write out the equation. So I'm going to start off with f of x. So let me go ahead and change that back to a pen here. So let me get rid of that. All right, here we go. So here we got f of x. F of x means that it's a function. So we're going to write out the function, and we're going to start off with our first piece. Well, that first piece has that equation, y is equal to x. So I just need that x part. I'm not going to write down the y equals. The y is our f of x. So x, and then that's going to be along the intervals of 0 to 5. And I'm going to write it in terms of the inequality. So it's between 0 and 5. And we stated earlier that we're going to include it in both of these. So it includes the 0 and the 5. Now the second piece is part B. And part B, that's when y is equal to 5. So I'm just going to write down 5. I'm just going to ignore that y equals because, again, that y equals is your f of x. And that's along the intervals of 5 to 10. So x is between 5 and 10. And again, since we've already included that 5 in the previous interval, we're not going to include it in this one. And then our next piece, that's part C. Well, that equation is y is equal to, so again, I'm going to ignore that y. And then we have 2 times x minus 10 plus 5. And then I'm going to go ahead and put in my comma and write in the interval. And that interval is between 10 and 15. So somewhere between 10 to 15. And again, since we used the 10 already, I'm not going to include it in this interval, but I will include that 15. And our last piece, the fourth piece, is that y is equal to -1x. Now you don't have to write the 1. Remember, we can ignore the 1. So negative, and then x minus 15 plus 15. That's the actual equation. If you do write that 1 for that -1, that's fine. And then that's along the intervals of 15 to 20. So x is between 15 and 20. And since we included the 15 in the previous interval, we're not going to include it in this one. And just to go ahead and put this all in one piece here, or one function, we go ahead and put this little braces here. And this right here is going to be our piecewise function. So all of this is our actual answer. Okay, so this is the equation of our piecewise function. All right, let's go ahead and take a look at one more as a quick example here. So in this case, they gave us a problem. It says the cost of renting a canoe is $20 for the first 4 hours and then $5 per hour for additional hours. So we want to sketch out the graph for the cost of renting a canoe from 0 to 8 hours, and then we're going to write out this piecewise function. So let's sketch out this graph here. So let's put in some scales here. I'm going to go ahead and let the bottom represent our hours, and then I'm going to let the y-axis represent our cost. And I'm going to start off with 0 at the end. So we got 1 hour, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, we're only graphing between 0 and 8 hours. So I'm going to stop at that 8. And then we know we started off with $20. So I'm going to count by tens here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and $100. Okay, so the first part, the first piece of our function is this. It says that it's going to cost $20 for the first 4 hours. So that means I'm going to go ahead and just draw a straight line for the first 4 hours at $20. So the first hour to the fourth hour is just going to be $20. So that's this piece right over here. Okay, the next piece or the next part of our graph is going to be $5 for any additional hours. So I'm going to constantly add $5 for every hour. So if I did that, that means I'm going to go up 5 and over 1 hour. So up $5 and over 1 hour. And then I'll do another $5 for another hour. So it's really going $10 for every 2 hours. So if I keep doing that, I'm going to keep moving up every $5 for every hour. And I'm going to stop right over here. Now, why would I stop right here? Why would I not continue? I'm not going to continue because it told us that it's going to stop for 8 hours. So we're renting from 0 to 8 hours. So I'm just going to draw my line here. And I'm going to stop at the 8-hour mark. So again, it told us from 0 to 8 hours. So that's where I'm going to stop. Okay, so there's my graph. There's my function. Now what I want to do is I want to come up with my equation. Now remember, we have two pieces here. Our first piece is this flat line. And then we have another piece where we have this slanted line where it's being charged $5 per hour. Okay, so now we're going to write out our pieces. We're going to write out our point slope form. Remember the point slope form, when we rearranged it, it now looks like y is equal to m times x minus x1 plus y1. So I'm going to start off with my first piece here. And my first piece, part A, I want to know what is that equation. Now, remember I said earlier that if we have a flat line, well, that means it's just going to be y is equal to that y value, which is 20. So y is equal to 20. And now that's along the intervals of 0 to 4. So that means the interval for this equation, y is equal to 20, is when x is between 0 and 4 hours. And we are going to include that 0 and that 4. Now the second piece, part B, is going to be a different equation. So we need our beginning point, and the beginning point is right over here at 4, 20. And remember to look at our scale. It's not 4, 2, but 4, 20. And then we have our slope. Now remember, we went up $5 for every hour. So that means the slope is $5 for every hour, which is equal to 5. So m is equal to 5. Okay, so if we take a look, we now have our x1 and our y1 from the beginning point at 420. And then all we got to do is substitute it into that format. Y is equal to m times x minus x1 plus y1. So our m value, again, we said is 5. That's our slope. And our x1 is 4. And our y1 is 20. Now, that's basically our equation. And now we want to look at the interval. So the interval, in this case, is from 4 to 8 hours. Remember, we're stopping at that 8-hour mark. So it's starting at 4 hours and we're ending at 8 hours. So our x values are anywhere between them. Now, I'm not going to include that 4. Why am I not going to include the 4? That's right, we already included before. So now, and then I'm just going to close up that 8. So I'm going to include that 8. All right, so now that we have all of this, we're going to use this information to come up with our actual equation for the piecewise function. So I'm going to highlight the information that we need. We need the equation and we need the intervals. So we have our equation and we have the interval. So now we're just going to go ahead and write out the equation. F of x, meaning we have a function, is equal to, and then we have two pieces here. Our first piece is y is equal to 20, so that's just 20. And then we have our comma, and then we got to write out the interval. Now the interval, again, I'm just going to copy it, is between 0 and 4, and we are including that 0 and that 4. And then for the second part, the second piece, that equation is 5 times x minus 4 plus 20. And that's along the intervals of 4 to 8. So that's between 4 and 8. And it does not include that 4 because we already used that before. So I'm not going to include it again. So we're not going to include that 4, but we are going to include that 8. Now all we got to do is draw these little braces over here, and that's going to go ahead and give us our equation of our piecewise function. Okay, so that's how you come up with a piecewise function, the equation of a piecewise function. I hope this helped out. If you have any questions, go ahead and feel free to leave a comment. Don't forget to give me a like and subscribe. All right, good luck, enjoy, and have fun.